All right, my mathletes. How's everybody doing out there? That's right, Mr. Muscarella coming at you again. And in this video, we're going to take a look at investigating the cotangent function as it relates to Desmos. We're going to look at some things graphically first. So it's just going to be a little introduction here. So let's go ahead and take a look at the cotangent function, shall we? Now, a couple things about the cotangent function. First, we've got to remember that it's this ratio of cosine over sine. So that's one of the pieces we want to remember. And cosine deals with the x-coordinate around the unit circle, and sine deals with the y-coordinate around the unit circle. So the points we're going to look at in particular around the unit circle are going to be 1, 0, negative 1, 0, and 0, 1. So we're going to look at those quadrantal angles again as we go through and do that. Now let's take a look first, though, graphically to see what's going on picture-wise with cosine curve. So here's what this is. So it kind of looks like the tangent curve, only flipped, if you will. Now, if I add in the cosine function, so there's a couple things we want to notice here. If we add the cosine function in, notice, there's going to be some spots where they intersect. So right here at pi over 2, they're going to be the same. Over here at 3 pi over 2, they're going to be the same. Now, keep in mind that when we look at 3 pi over 2, that's the positive revolution. We're going around in a positive direction in the unit circle, but don't forget, we can also go in this direction. So 3 pi over 2 and negative pi over 2, they're both going to be the same location around the unit circle. So that's just something to remember there. So negative pi over 2, so if I go over here to negative pi over 2 in Desmos, we get the same y value. Both of those have y values of 0, whether we're at 3 pi over 2 or negative pi over 2, because they both talk about the same space. Now, there's other areas here where we look at and we can see like, we've got these vertical asymptotes going on because the graph looks like, hey, oops, turn that one back on. It looks like the graph shoots up forever and also shoots down forever. So it's going to approach positive infinity and negative infinity on opposite sides of our asymptotes. But then I want you to notice where these things happen. So again, I'm going to put the cosine curve back in there, and that's right here at 0. So that's at a maximum. And over here down at pi, where we're at negative 1. So anywhere the cosine is at its maximum or minimum is where we're going to have these apparent spikes where the graph goes up forever or where it goes down forever, depending on which side we're approaching from. So that's going to be something that we noticed. And let's add in where those vertical asymptotes are. There we go. We've got all those pieces in there. So the asymptotes are only pi apart. Same thing as what tangent was. However, they're just shifted to the left, if you will, pi over 2 units. So that's one of the things we want to take a notice of and become aware of as we look at graphing the cotangent curve, because it's going to look almost similar to the tangent curve, but again, flipped, and the asymptotes shift. And notice the length between, or the distance between the asymptotes, they're going to be pi apart, because if you look at the distance between 0 and pi, or pi and 2 pi, or 2 pi and 3 pi, or 0 and negative pi, that distance is always going to be pi. So that's going to play into account when we go and take a look at this. So we'll come back in the next video and then continue to fill out our chart and go through the notes on this section. So thank you guys so much for watching this one. I'll see you in a couple moments in the next one. Thanks for watching, and make it a great day. Peace out.